Now I'll go ahead and introduce myself. My name is Eric Glenn. I'm the program manager at For Safety. We appreciate you joining the webinar on an intelligent visual discovery mapping platform for massive heterogeneous data sets. You have all come into the meeting muted until the Q&A session. If you have any questions during the webinar, please type them into the chat box. They will be addressed at the end. You can get to the chat box if you scroll your cursor down. You'll see in the polls and the participants part right here, you'll see chat. You just click chat and then you can type it in. We will have the captions on for your convenience, and let me go ahead and put that on right now for you. Let's see. Transition. Enable. Perfect. All right. And at this time, I'd like to introduce the presenter and also the presenters. So Dr. Shui Yi is Harold L. Adams Endowed Associate Professor in Urban Planning and Provost Investment Hire of Urban Informatics at Texas A&M University. He is also a fellow of American Association of Geographers. His research focuses on geospatial artificial intelligence, smart cities, spatial econometrics, and urban computing. His research has been supported by federal agencies such as the U.S. National Science Foundation, the Department of Transportation, the Department of Commerce, the Department of Energy, and the National Institute of Justice. I'd also like to introduce Jeremy Neitz, a researcher at Virginia Tech Transportation Institute. He will be giving a formal introduction to the Dataverse as well. Now that the introductions are out the way, I can turn it over to Jeremy. Let's see.
Sure.
Yeah.
Okay. Hi, so I'm Jeremy Sudweeks. I'm a senior researcher at Virginia Tech. I just wanted to take a quick minute to kind of speak to the Dataverse platform that we host at Virginia Tech. I think a significant portion of some portion of Dr. Yi's presentation is on Dataverse or Datasets hosted by Dataverse. So the safety UTC data is hosted in an instance of Dataverse that VTTI maintains. There's also some other data assets, including some Sharp2 citations that are available. And so we found Dataverse to be a really useful platform for sharing data. Even some of the protected data sets we have, we provide citations so we can make people aware of what's available and then work through the process of being able to provide it. So just wanted to make people aware as they listen to kind of the presentation that the Dataverse platform is something that is being made use of by the safety UTC. And so I want to leave as much time as possible to Dr. Yi. So I think with that, I will turn the floor over to him. So.
Thank you, Eric, and thank you, Jeremy, for starting the nice introduction. And I'm Qing Yuan from Texas A&M, and thanks again to the platform CPD provided so I can give the talk today. So let me share my screen. Today I will share some of my work on developing intelligent visual discovery mapping platform for massive heterogeneous datasets. Currently, I am co-PI for two CPD projects, Endeavor and building equitable safe streets for all data-driven approach and computational tool. I have used the Dataverse before. Interestingly, I just learned Virginia Tech and the CPD utilize the Dataverse to archive data and to share the research. So I'm thinking about some of my current projects very much previous research also relevant to utilize this Dataverse and to be more specific to building the open knowledge network, allowing the data sharing to be more easy and also more productive. So for Dataverse, I know many people might know or might not know Dataverse. Let me very quickly go through my understanding of Dataverse. It was established by a very famous scientist and scholar, Dr. Gary King at Harvard University in 2006. So it starts for social science data sharing, but now it becomes a worldwide platform for all disciplines. So for that is I also check total file downloads and total data sets available in the recent stats from the Dataverse. It's amazingly, if you look at over the monthly, the peak growth. So at the same time, when you look at the Dataverse efforts, definitely you might, for some of you, if you utilize data.gov, which also have a large amount of data, like and the more data in DataMed is very much run by National Institute of Health. So in other words, data everywhere. There are many open source data. However, the big problem is most researchers only download and review datasets they already know about, but have difficulties in discovering the unknown. That's very similar to us when we do research. Most of the time, we follow similar topics or follow the researchers we know. However, every day there are so many publications, so many new researchers. How is it possible we can follow everyone's research? So that would, so in other words, even you have like 10,000 data sets or 1 million data sets, maybe you only use 1 or 2 of them. In the industry, there's an interesting trend. If you look at the Florida opened Amazon supermarket, it does not have any checkout lines. Alexa assistants will help answer your question. So in other words, the Alexa, it means this Alexa should know every goods, every stuff to be sold in this supermarket. Otherwise, how they can not only answer one type of question, they answer every question. So for that, there is a totally equate a need is since data is grow day by day. If you look at the previous slide, the data grows very fast, but we do not have the capability to utilize all the data. At the same time, while we accumulate these data sets, I have been working on a National Science Foundation project to look at the wildfires, biodiversity, also look at the water quality. And for that, it's a typical very compressed problem. We need to share knowledge across the kind of the organization at the administrative boundary. Decision makers, very difficult to find data workflows or algorithm in the real time because no one there's no one expert will know everything about data. Where is the data? Right? Especially during the real-time decision making, it's a big challenge now. So National Science Foundation has come up promote something called Convergence Accelerator. What is really interesting, I think we should become a philosophy to organize and make the most out of Dataverse is something called Open Knowledge Network. So Open Knowledge Network is why we put together so many information and data together. It will allow us to create a new understanding. At this moment, many of our data sets and practice are isolated from each other, even in the Dataverse. Dataverse give you the credits if you upload the data, upload the procedure. However, even at this moment, Dataverse use Google style keyword style searching. So in other words, firstly you need to know which you want by keyword. But some other, we also know is in the discipline, very possibly we have some other very relevant research topics are using different keywords we are familiar with. Then it means these data sets will be out of our eyesight. So the National Science Foundation Convergence Accelerator is help us build some tool which allow us to identify, harvest, and incorporate the data sets for the network. So in other words, building the network for data. Some years ago, I think it's 4 years ago, there is a very important workshop. It's called Open Knowledge Network. It's called Big Data IWG workshop. And they released kind of the summary. In the summary, I quoted the key takeaways here. So we are talking about the data, the real world information updates and changes. They will happen every second. Our kind of the data archiving strategy need to capture the dynamic. Second is it need to be open to accommodate input from many different sources, able to link the disparate information. And it should also have horizontal and vertical elements. A good example of horizontal elements, it means it's more from computational perspective. It means your Dataverse or Dataverse-like data archiving platform need to be really easy for query, allow you to integrate different data sources, and it should have a user-friendly interface. How friendly it should be? Think about the Google search. At Google, you can type some really kind of the unclear ideas. Google still will return something reasonable to you. Then you can search again. So that is as natural or as user-friendly as possible. But for vertical activities are equally important because while people spend time searching data, many of them are for research purpose or for the kind of the research purpose or for search some critical information in real time. So you really need to build some representative sets of queries to serve them, and also design some prototypes for them to have some functionable scenario immediately. So for that is open knowledge network, as I said, is data regardless of how the quantity has limited utility if it's not well integrated. But now many of our research on open knowledge network is from business purpose, like in Amazon. And as I said, even in some supermarket, the Alexa, the question and answer assistant is much better than any academic search. So we want to promote this type of the research. That's what I have been doing. And if you want to ask is, what we can do more than Google can provide? So because doing research and for search, Google is totally different. Because search Google is very much for fun, for your daily life. But for research, you have certainly hierarchical order to ask a research question. For example, the following research question cannot be asked by Google, but it can be answered by, if you prepare the data sets, organizing them with knowledge network, right? Because Google will not understand what was the trend in air quality last month in Bethesda, Maryland. And if more academically, find visual data for the last 50 years in partisan data. That's not a Google like to answer. This is very kind of academic or very domain specific. However, if Dataverse organizing the data in more like a knowledge graph, open knowledge network style, it can also answer this question that will be showing later in my video. Yes, so as I said before, is a horizontal domains, building query, integration, and user-friendly interfaces, while the vertical domains mainly focus on the domain use. So in other words, come up a killer level case study for utilize data. So data is weaved together. So I have been involved in an international organization called Spatial Decision Support Consortium. I'm the vice president of this consortium, and we are building. It's open. If you search this consortium, you will find out we open our projects here. All these projects are talking about how to better archive data, archive model, and share it publicly. So we are thinking about the decision support can be further facilitated. So if we are linking the archive data model together, not only that, we also bring the stakeholder and the decision maker and the scholars together. And we building, so for us, is everything become data. Like we are working with people on water quality, and we hold quite a few workshops. All the meeting notes become data. And these meeting notes point to the collaborator and the other agency. So we are so allowing us to easily to search who we should ask for help or who we should point to. So nowadays, when everyone contribute the data into the Dataverse, at the same time, it's also a community of scholars. So we are not only search data, we can also research people. So that's something in our spatial decision support do is build a large cloud service allowing us to link the information together. And we also think about how to sustain the network tool by extending our prototypes. So in the rest of some minutes, I will play with some. First, I go through some of my research. Utilize first through starting from Dataverse and many other Dataverse style data portals, showing you how I link things together for easy query and the data service and definitely research collaboration. This is a typical, we developed some smart data finder as a plugin for Dataverse. I have presented this before in the Dataverse annual conference held in Harvard some years ago. And this is our interface. I think the organizer already put some video in for you to view. I will share it again. Okay, so for that is we link many data sets together, and for each point represent a data set, and it will allow you to link to the specific data set hidden in Dataverse. And for that is we are building a software allow you to it even will allow you to auto-complete for search queries. It's almost like Google. When you type in a Google keyword, even before you finish typing, Google will give you the hint. Is you probably want to type these words, it will give you a list of things. And we allow us to visualize all these word cloud visualization of relationships between relationships is because why some data sets they share similar, the more data keywords they share, they are more close relevant. And where this is, as I mentioned, the water quality search is we go to import all the meeting notes of the water quality volunteer groups meeting notes. Plus, there are some literature. So then for that is we're building another kind of the interface, allowing us to link the scientific literature and the community need. And in addition, if we want, this is another awarded project, is go to search many COVID-19 relevant publications. I developed the platform one. Before I came to ANN, I was in the Institute of Technology. So for that is you see a big kind of cloud here. Actually, this is almost 500,000 papers are here. So why some similar color? When they have similar color, they have similar research questions. So in other words, you can see all the papers together in one place. Then they can classify it into different clusters. Then you can definitely increase the number of clusters. You can further zoom in. You will see more small clusters, reading clusters. And when we put together the archived data or archived model, there's one more thing is we are talking about it can even help us to build the body of knowledge for a discipline, right? But what does the body of knowledge look like? Is if you grab a textbook. In the textbook, you have all the name of chapters and also have section, title, subsection title. You put them together in hierarchical order. That's your discipline body of knowledge structure. So we have been thinking is like my discipline, my PhD in geographical information science. Our organization developed this online, but we still think we cannot capture every day's new literature. So what we do is we go to grab all the papers. We can search millions of papers downloadable online. Go to match the structure from the textbook, from the other major organizations. We summarize my discipline, the knowledge structure. Then we merge the papers to the structure. Think about it, we have grow a tree, a big tree. For a tree, each branch, each sub-discipline, subtopic is supported by paper, but certainly it's also supported by data. You can consider paper as data. And you can also consider the open source data sets provided by a paper is also a data. So for that, we're building a huge tree. It's a very beautiful tree. It's in my this is in my research web page. Is we call it GIS 3D knowledge graph, 3-dimensional knowledge graph, and we can zoom in for each subdiscipline. So let me share you some videos so it will make things much clearer. Okay, so let me share again, share the once video. First, let me show you some of my COVID research.
Hi, I'm here to representing the COVID-19 Open Research Dataset Search System. And this system is still under development, so you might have it might have a different look when you open this website. We think research papers are important assets for scientists when we're fighting COVID-19. So we made this map here. Every dot here is a research paper. We use advanced natural language processing models to embed them to 2 dimensions. So if 2 nodes are very close to each other, it means they share lots of similarities. For example, semantic similarities and other research field similarities. And we also run cluster algorithms. So all the research papers can be clustered to 5 or any cluster you want. And you can see it from here, the keywords in each cluster, and see what the meaning of each cluster. And we also have different language models, so the nodes can show the different perspective. We also provide the search engine. You can search for abstract in the research papers, search for the body text, search the figures and tables, and search the research paper's titles. The paragraph means you can have the paragraph level search results. For example, if we search cough here, and we can get there are about 344 papers about cough, and we just show 100 here. And the keywords cough are highlighted in each article, and you can see how those research papers are describing cough. We also put a map. The map shows we extract location names from all the research papers. So you can see where is the hot research area in the world. For example, China here is a hot topic, and I think New York here is also a research topic. And this map gives us guidance. We can see where is the hot area, and maybe there are some countries no one is doing research on, and it might be needed. And if you click zoom into the certain area, it will show more granular research paper distribution, and click certain dots. It can retrieve the research paper titles and the link to the original paper. And if you have lots of, for example, 6 research papers in those areas, it will show in the toolkit. Okay, thank you for this short video. We also have a tutorial in our main web page. You can click and see what functions we are developing and how they can work. Thank you very much.
Let me show you another thing, which is the kind of the using Dataverse.
Welcome to the introduction video for Smart Data Finder tool. We aim to build a knowledge discovery tool. All the data in the demo is provided by the Dataverse API. And we build a workflow to import data to the graph database. Here we use Neo4j and use default visualization to present sample data. Different colors here means different kinds of information. For example, blue is keywords, orange is the raw dataset. We build our own search interface in front of that. First thing is, enter a search term in the autocomplete text entry. It will autocomplete the query. Here we choose crime and show relevant results. Check the help box to read the help text. Each node represents a keyword appearing in the result datasets. Terms frequently occurring in the same datasets are linked and placed close to each other. Big nodes means terms appearing in more result datasets. Green means terms appear more frequently in the result datasets than in other datasets. Use mouse wheel to zoom in or zoom out. Drag and drop in an empty space to pan the graph. Drag the right bottom corner to enlarge the canvas. Check the lens box and drag and drop to activate the lens. Read the labels of selected nodes from the tag cloud. Move the lens around to learn more keywords. So the relationship between different datasets will present to use clearly. We hope researchers can be inspired by such datasets relationship exploration. Right-click a tag to add it as a filter term. Click the term to remove it from filter terms. Add a new filter term. Add one more filter term. Use the lens to examine the keywords in the filtered datasets. Add one more filter term. Browse the datasets. Click a link to open the dataset in its repository webpage. We are adding more features to this tool. This scatter plot shows temporal information, also allows users to interact with datasets based on time. Thank you for watching this video.
And this video I showed so far is what we developed with Dataverse team to allowing us to linking data quick together. The previous video is if you look at the interface, it's very similar to what we developed for Dataverse. But for that, we incorporated the other datasets, the publication datasets. And I have one more here is utilizing the question and answer system. That's very useful for people who are doing community engagement, who need the
Our New Jersey Institute of Technology team has developed a question and answer tool that you can think of as a specialized Google search engine for research questions. So let's scroll down and enter stormwater. As in any search tool, you just type a question or phrase you want to ask the system, and relevant resources are returned. What we're seeing here are a selection of the 30,000 plus water quality related research papers whose abstracts we've indexed for this collection. But this tool goes deeper. We've interviewed people involved with water quality, wildland fire, and biodiversity, and collected many need-to-know questions and concerns. We also input the hundreds of different learning objectives from the GIS&T body of knowledge. The team used advanced language models to encode this content and convert it to two-dimensional vectors. Each dot in this map represents one question or concern, or a learning objective. It's a way to visualize similarities between different research questions or collections of knowledge. Dots near each other are more related. The system can then identify clusters of text with similar meanings, and a human expert assigns a label to the semantic categories. Cluster labels are on the right and color-coded by domain. For example, let's zoom in to one particular interview quote. My biggest concern regarding water quality in Puget Sound relates to water quantity, that people treat stream flow and water quality as separate realms. The text itself is then searched via the knowledge graph to see who is currently addressing it. Oliver Graw is the water resources manager at the Nooksack tribes who was interviewed and voiced this concern. Inference through the knowledge graph also identified two other individuals who've been working on a study related to that concern. The same search execution can currently retrieve the most relevant abstracts for that quote. Again, if we wish, we can use the hyperlinks to access the articles themselves. In Phase 2, we'll exploit the knowledge graph to return more resource types, models, tools, workflows, related maps, etc. Leveraging machine learning to help us understand relationships between questions and answers means we can tackle difficult issues when it comes to synthesizing knowledge from different domains and communities.
Yes, example from the water quality question and answer is it further go beyond of using the data publications or models. It go to link with the meeting notes because the bigger philosophy of Dataverse is we need to share our data, share our research, make social science research more transparent. Definitely now it also expanded to all other disciplines. Still, social science is the core of the Dataverse. But anyway, behind that, if we want to make the most out of Dataverse, is we are not only linking the data, also link the publication, link people discussion notes, and eventually we link to experts. So almost like nowadays, if you search a researcher in Google, you will see a knowledge panel coming out in the Google search. It will show you the people, the graduation, school, this person, the experts, the books, or you will find out you are also searching other people because it will show you this person and the other person, a list of other person. It means those people either have collaborated before, or if you want to get hold of this person is too busy, then you can search, look for the alternative, right? So the alternatives are the scholars who have some close collaboration with this scholar. So for my rest of my talk is okay. Let me think. My rest of talk is regarding the next step, what I can think for the Dataverse relevant research is I want to borrow the ideas from the knowledge network workshop report released 4 years ago. I still think that these 1, 2, 3, 4, 5 steps are really worthy for further pursuing the efforts. The first is we need to further build the natural language interface for spatial and temporal aspects of open knowledge network. In other words, now, like I say, we archive data to a Dataverse, and the data has a temporal aspect. We know when the data was uploaded and which time period does the data represent. And we also know, for example, which city, which town. So we need a kind of the temporal trend and also geographical map telling us where are the data, right? Because our research, we either want to find the data in the same town or city, but we might also find the city and the town which is similar to our study site. The second is we also need to assess data quality and uncertainty. That's another bigger thing for open source development. Different from commercial software, because commercial software, commercial data provider, they charge you money. So you certainly you have the greater rights to ask them to verify the data quality and uncertainty. For open source, how you can utilize, so there should have a mechanism for allowing us to assess what the data quality and the uncertainty is. And at this moment, I know Dataverse, when you upload, why Dataverse give you the DOI for your uploading data? Because previously, people provide data, provide the procedure are not considered a publication. When Dataverse gives you DOI, it's acknowledgement from the scientific communities. You make a contribution, you have the DOI also represents you have a publication. So that's one step, but we need one step further. Since you acknowledge people, you need, when you putting data together, you need to know who did the data collection. Which data center support that? For example, Virginia Tech spent lots of efforts of building Dataverse for safety. Then in the future, Virginia Tech should be cited for this effort. And if another center also runs a similar data products, then probably we also need to verify whether there is any inconsistency. And we'll, as I mentioned, as I mentioned, is data is good, but data will expire. Real-time data is important, allowing us to always make a timely decision. But we also need the real-time data because some decision is better without the expired data. It will make things worse. So we need to know, it's like almost we eat food. We need to know when the food product will expire. So we will not eat some food will expire. And we need to have, as I said, when we allowing the customers sending more question in, we are building what if scenario. That will make it is more interesting to the researchers and the policymakers. So that's all for my talk. And as I was reminded, I need to keep about 15 minutes also for the question and answer. Please ask any questions if you like. Thank you. Hi, Sue.
Thank you. Thank you, Dr. Yi. So right now, we're going to go ahead and start the Q&A. And we do have several questions. The first question came through the chat box. And this is can you include in the chat the websites and the papers that you have mentioned? I did include just the project site on there.
Yes.
But I can also, what I can do is if you send it to me, Dr. Yi, I can send it to everybody.
Okay, I will.
In an email.
Sure, so I will.
Everybody has that.
Yeah.
And then Sue has her hand up. So Sue, if you can go ahead and unmute and ask your question.
I was just wondering for the text searches, are you looking in the data dictionary for those text strings or in the data sets themselves?
Oh, guys, at this moment, I have in the 3 videos for when I share the Dataverse one, I only utilize the Dataverse metadata. So in other words, when you upload the data product, you will also provide the metadata for the data. So metadata is searchable. So we can utilize the metadata. For example, in metadata, you have keywords of the data product. You also have data provider for the key data, right? So I use metadata for the one video, but for the COVID-19, I go one step further because COVID-19 publication at that time is they make it a totally open source. That means the full paper is open source. So that means I can go into each caption of the figures, tables, the text inside. So for that, we are doing more like a detailed search. And for the third video about water quality, for that is we have the full code of their meeting notes. For the meeting notes, there's no keywords for meeting notes, but we search the full document of the meeting notes. So for that is also the full text.
So do you have any advice for people who are preparing a data set to upload in terms of what is useful metadata to include?
I think at this time, Dataverse already did a great job because Dataverse, when there's a guideline for telling you how you upload data set, I think Dataverse already did a great thing. Even nowadays, because the limitation in the time efforts I can contribute at that time for the Dataverse development, the visualization development, there's still many rich information have not been further digged out. I have been even thinking about is, for example, for each data verse, provider, it has certainly has authors and co-authors. And I know some people, when they upload the data, they also upload their relevant publications. I have been thinking about is what I call the heterogeneous data sets. Is data is not a person, but the author of the data is a person. If it's a person, the person will have publication record. The person will have co-authors. And I can use data to link to many elements is behind that. So in other words, sometimes sometimes when I follow a person in research, because I know this person is a big name, so I follow him. But sometimes I only want to follow the research theme. So if our search can allow you to search the person you want to follow and the research theme you want to follow together, it will allow you to maximize the data sets you can find.
Mm-hmm. Okay, thank you.
Thank you.
Yep. Thank you, Sue. Are there any other questions out there?
Hi, my name is Maria Esteva, and I am wondering if you did any usability study to find out, whether you really have to spend, the way I see these, and it's really interesting in terms of Dataverse that is so diverse, in terms of its content. It is interesting to see the interface. I think it's wonderful, but I wonder if you did any study to see how much time a researcher will have to spend browsing and filtering and looking, to see whether these data sets are, because Dataverse, one thing is to work within a very domain-specific data repository, but Dataverse is all over the place. So I wonder if you have done any usability study with your interface. And
oh, that's a fantastic question. I will send a list of my relevant publications to Eric. He will show to everyone. But that's a long story short. Short answer is I did one user study actually for the COVID-19 paper research, because people said the COVID-19 paper, because they publish almost every day, have dozens of papers coming out. Before you digest the one paper, the other paper come out, so it makes the scientific advance almost impossible, because you haven't read a paper, how you can move on the other people's advances. For the Dataverse, since at that time our team building the visualization thing for Dataverse, we have submitted a proposal with Harvard team, but unfortunately we didn't get funded. And so then we didn't further move on. I really love to use Dataverse tool to further test, and maybe we can do this safety opportunity, since Virginia Tech now are putting the using Dataverse to do the kind of the for safety project. I think the thing is, if we can use that tool is without impossible. So it means if I don't need any visualization platform, I just use Dataverse platform. How I can easily find something useful to you, or using more video, like in video analytics platform suggested by me, it probably will allow you to link to some other data sets. So my philosophy is the actual usefulness of the video analytics platform is not only looking at a specific subset of Dataverse datasets. For example, they accumulate 20 datasets, only have 20, then you only look at 20. My thinking is it would not be useful if your datasets is very limited in number. It would be very useful if it allows you to find out the unknown linkages of the other datasets which is in the database, but you never were this data set as has a connection to your research field.
Okay,
Right.
thank you. I
Yeah.
see.
Thank you.
Thank you, Maria. And are there any other questions?
And one more thing I want to add here is, Erica, I don't know, maybe if you search my name and university, you can very easily find my email address and contact information. I'm more than happy to collaborate with everyone here if you have the specific need, because my expertise or strength, I consider myself more like a computational social scientist and a data scientist. And I know any platform will be really useful and of greater importance if it really serve a case study need. Because many times we develop a platform, we want to have some, we call it killer levels, case study or demo, right? So yeah, let me know. Because as I will show our publications through Erica, to build my discipline, the knowledge graph, we can go to search several million papers, download and building the data structure and link them together. So for me, the computing and extremely large scale computing is not a limit. I think what limits us is a really interesting research question.
Yeah, and Dr. Lee, thank you for your passion in this. You can really tell that you exuded when you were talking about this topic. So what I would do.
I also want to throw a question back to Jeremy. Is I'm excited to know that Virginia Tech are using Dataverse, and I search online. I noticed that there's not at this time not many datasets are in the Dataverse portal for Virginia Tech. So do you have any plan to maximize or promote other people to using the Dataverse?
Yeah. So
Thanks,
do I have time, Eric?
Yeah, you do have time.
Okay. So the safety Dataverse does have data sets in it. For some of the other data sets, particularly SHARP2, we can't release that data without a data use license. So we can't host the data in the repository, but we have the citations there. So if people reach out to us, then we work through the process of getting a DUL in place. So we have some PII concerns that kind of limit how much of the data we can actually host on the platform. So, but to the extent we can, some of the other instances of Dataverse, some of the truck data sets have some data that are available there. So, we have constraints that we work within. So.
Good. I also look forward, and Jeremy, we can keep in touch. I look forward to collaborate with you further on promote the Dataverse in safety and transportation research. I noticed the ENM also have a safety portal, the Dataverse portal. When I came here, I know the ENM is also part of the Dataverse community.
Yep, absolutely. I'd be happy to collaborate.
Yeah. Any other questions?
No, if you can send papers, I mean, you got the website and the YouTube, but if you have published papers, that would be interesting.
Yes, I will send to Erica. I will send you a list of the most relevant papers. Yeah. So I would say that now the knowledge graph is one of my major research directions. For me, I think that if Dataverse need to be further utilized and maximized, they really need to build the knowledge graph into the Dataverse to make it smarter to be easier to be defined, think about how Google invests so many efforts in building knowledge graph. So that's the reason why people like to use Google to search. Yes, thank you. Okay.
All right. Well, yep. Thank you, everyone. And yep, we should be. Dr. You would send me all the information, and I'll put that in an email to be sent out to everyone. So again, thank you all for joining the webinar. This webinar will be uploaded to YouTube, and I'll notify everybody via email when that's complete, along with sending all the documents and the links. Our next webinar will be on crash compatibility of automated vehicles with passenger vehicles, which is set for February 24th, a month from now, at 2 p.m. Eastern Standard Time. So a free registration will be up soon, and I'll send an email out. And it's also on the safety website, along with any upcoming safety websites. I'm sorry, any upcoming safety webinars. So thank you all again. Enjoyed it, and look forward to seeing you all in the next one.
Thank you. I also typed my email address in the chat box, but you can easily search my information online. Thank you. Thank you, Erica. Thank you.
Thank you, Dr.